Hi everyone, we're live with our next speaker for the day, who's our third speaker. He's going to speak about software composition analysis, free and open source software security. So, Abhishek, would like to give it to you and you can take the session ahead.
Thank you, Vandana. Yeah. So I'll start by sharing my screen first.
Sure.
Can you all see my screen now?
Yes, we can see your screen.
Okay. So
You're all
today,
good to go.
we're speaking on software composition analysis, which is one of the domains in application security. Before that, I'll have a quick introduction of myself. So I'm Abhisek Kumar. I'm working as a security consultant with Synopsys. I have close to 3 years of experience in information security, and I am available on these below links. I regularly write blogs on Medium on security topics, so you can find me there. And apart from that, my current work areas is secure code review. I do software composition analysis and regular VAPT for mobile and web application. So that's a little about myself. So we'll start with our session, which is so we'll first look at our agendas. In our today's agenda, we have so we'll touch upon the introduction. We'll get started with the introduction. So what open source softwares are, what is software composition analysis, and we'll move on to the challenges or the risks associated with software composition analysis and use of open source software in your project. We'll support our understanding with case studies, some of the case studies that I've prepared. And also we'll see in the end, we'll see the approach, what we can follow in order to achieve and conduct software composition analysis. And in the comment section, you can drop any questions you have. So that's all for today. We are going to talk. So let's get started. So before diving right into software composition analysis, let's talk a little about, let's revisit open source software. So what is open source software? It is essentially a free software which is out there in the open on the internet. So there is a community, open source community for that company, which is creating it, maintaining it, patching it, and doing all which is required. So this is what an open source software is. And almost all the open source software comes with licenses. So they have their own terms and conditions and license obligations with them. So on the right hand side, we can see the uses of open source software, which the evolution of the usage, which are so in the late 90s, we can see there were only 10% of the projects which were using open source components, software or libraries, anything. And today we can see it is actually more than 90%. So we'll focus on the users more on our next slide. So here on the left, we can see almost like 99% of the code bases which were audited contained open source components, libraries, or code snippet in one way or the other. Also, out of the 17 industries, 9 of them contained 100%, like all of the code bases were open source codes. And on an average, if we see, like 70% of the code base is open source code. So you have like close to 30%, which is your custom code that you're writing, and the remaining is the open source components, software or code, whatever you are importing out from the open source community. Right. So this is the current user scenario that we have. On the right hand side, we can also see the top open source components which are being used in the industry currently. On top, there is jQuery, then followed by Bootstrap and some other very popular open source components. So, so now let's understand what is software composition analysis and how it is important. So in simple words, software composition analysis is nothing just a practice or an exercise of identifying all the open source and the third party components in your application software. Okay, so you might come with a question. So we already have secure code review. We already have our DAST at the end of the life cycle in our application security pipeline. Then why do we need this software composition analysis? And more importantly, where do we need this software composition analysis? So we'll see that in a bit. As we saw in our previous slides, almost 70% of the code that is there in your code base is open source component. And while doing software, your secure code review, the assessor only focuses on the custom code that is written by the developers, that the organization developers. So it is essentially covering only the custom 30% of the code, and it is getting reviewed for security vulnerabilities. So even if the 30% of the code that you have written is safe and secure, so there is a risk on that 70% of that open source software or the code that you're importing it, that needs to be reviewed and analyzed as well. So that's where this software composition analysis comes into the picture. So while doing the software composition analysis, one very pivotal thing is coming up with a component inventory that is also called a bill of material. So it is nothing just a list of all the components that is getting used in your project or software, whatever it is. Also, so what is this bill of material used for? So we use this bill of material to find out the associated risks, which are namely the operational, security, and the licenses risk that are there. So we'll see in a little detail what this bill of material is and what purpose does it serve. Okay. So the basic definition, a software bill of material is a list of all the open source and third-party components present in your code base. So it allows the organization to track all the components. In other words, it gives you visibility, like what are the open source components, or rather the components being used in your application or the project. So this gives you this helps you a lot in managing your entire project so that you can see other risks associated with those components. So similarly, the third point talks about how do we come up with this sort bill of material. So there are two ways, the manual way and the automated solution. We'll see the manual and the automated solution both in detail in a bit in our later slides. So in the image below, you can see like bill of material is nothing but just equals to all the components that are there in your project or application software, whatever. So with this, let's move on to the challenges that we have in open source security or open source software rather. So namely, there are three operational, security and licenses, risks or challenges associated, and we are going to talk about them today. So let's start our discussion with the first one, the operational challenges. So while dealing with the operational challenges, it mostly focuses on the operationability of your project, the smooth conduct of your entire project management and all. So you might come across these points. You will ponder upon these questions. Like for example, how much open source are we using? As we saw in the previous slide, like on an average, 70% of the code is open source. So you also want to have a look. What is the status of my project? How much of it is open source? Similarly, how is the use of open source reviewed or governed? Are there any policies in my organization which manages and regularizes the use of this open source softwares in my app in my projects? This is called the FOSS, free and open source software policies. Are they there in my organization, or do we have to come up with them? Similarly, how big is the open source component community that we are using? Why do we need this? As in, if any support is required, for example, integration in your application or any kind of security support or anything. So it's better to have a very big and active community so that you can solve all your problems that you come up with. Again, how many components are running on outdated version? This is a very common problem, using an outdated version of the components. Many of the projects you will see the components have the present, a latest version of it, but they are not getting used. So this can lead to a lot of issues. We'll talk about them in the security section. Again, how often are those security bugs or issues patched by the community? This is really critical while deciding whether to go with this component or not. And the last one, what could be the alternate solution? If the community is not issuing any patch, what can we do? At last, we'll have to write it ourselves. That's the last solution. But again, it's better to have alternate components or free softwares ready. So this is all about the operational challenges that we can face while deciding a component, the open source component we can use or not. Okay. So next, very important and very big is the security risks. So what are they in SCA? So actually, they are the security issues that come up with your open source component that you're using. So it is that important. You might question the importance of it, the SCA, but this thing has become so important and relevant in the last couple of years that even in the current OWASP, you will find this at number 9, using components with known vulnerabilities. See, this is something that you cannot ignore because at least you should follow us top 10 while doing the security review of your application. Okay. So this is a basic of security risk and we'll talk in little detail about this. So while checking the security risks, you will come upon these questions. So what do our projects have open source vulnerabilities? That means the open source components that we are using, are they vulnerable or not? Second one, how many of those components are vulnerable and are actually being used in our application? That is something you want to analyze and check while performing a comprehensive software composition analysis. The third one is very so understanding what those vulnerabilities are. Are there any critical or high? Depending on the sensitivity or criticality of our application, you can decide whether to go ahead with these components or not. So these are some of the deciding factors you should keep in mind. So to support our whatever understanding we have got so far about security risks involved in using open source softwares, so let's see a case study. So here we'll talk about the famous Equifax hack that happened in year 2017. So Equifax is one of the 4 big credit reporting agencies which actually stores a lot of sensitive personal data that includes personal information and the sensitive information such as credit card information. So a hack happened in Equifax which revealed close to 148 million individual records. That was a very big hack. So there were multiple factors which led to this hack. One of them was like the username and the password was not encrypted. It was in plain text. The certificate has expired. But the major name that stood out was the Apache Struts vulnerability. So that vulnerability is also dubbed as CV5638. So it was actually a vulnerability in the Apache Struts version 2, where you can send in a malicious code or a payload through the request content type header. And these struts could be tricked into executing it, and you can achieve a code execution attack. And that's exactly what the attackers did. And they got inside the system of Equifax and revealed and steal all the data. Although Apache had issued a patch for this in the month of March, but somehow it was missed and was not upgraded by Equifax. So that's how this whole attack happened. So now we can see what could have been done to protect it, the remediation part. So if there was effective software composition analysis in place, they could have identified all the Apache Struts instances where it is being used, and as remediation, they could have upgraded it to the latest patched version instead of that old vulnerable version. It was that simple. So that's what the importance of software composition analysis is in if you're using open source components in your application. So so now we'll come to the licensing risk that we have. So there are 3 risks that we are talking about. So two are already covered. The security risk is huge. So is the licensing risk. So what are the licensing risks? So as I mentioned, every open source component has licenses attached to it. Right? When you're publishing your open source library, component, or code, anything, you give a license, and there are certain terms and conditions and obligation that needs to be followed. So licensing risk are basically the conflicts that you get if you're using an open source components, and if you're distributing your software to your clients or using it for some purpose, then there could be some license conflicts. These are actually the licensing issues or the risk. So we'll see some of the questions that we may come across when dealing with licensing risk of open source softwares. Okay. Do we have any non-compliant licenses with our FOSS policy, free and open source policy? We'll try to find whether the licenses that are being used are they compliant with our own organization FOSS policy or not. So for that, we can maintain a list of licenses. We can separate them by a blacklisted list of licenses and a whitelisted list of licenses. Where in blacklisted, you will see these are unsafe ones. You cannot use them in my organization. We cannot allow them. Similarly, whitelisted would contain all the licenses which are good to go with. Similarly, we will also have a detailed look at our distribution models because many of the licenses obligations are directly dependent on the distribution models that you will use for when you have created a software and you are distributing it to your consumers or your client or your vendors, anyone. So that's little about licensing risks. So in order to understand this entire licensing thing, so let's see the different licenses families we have. So here I have used the color coding. The red indicates the very restrictive one, the stringent one, and the green is the permissive one, which is a friendly license, you can call it. The first one is Affero General Public Licenses. It is also called as AGPL popularly. But this one is very restrictive, and you should be really careful while using this kind of license in your application because this can seriously jeopardize the ownership of your project or the code or anything. So what is essentially mandates if you're using this AGPL licenses, then you have to make your source code available, like source code. You have to share your source code. So, and similarly in reciprocal also, it mandates the same. If you're using a reciprocal licenses, you have to share your source code. But after AGPL licenses is much more restrictive than reciprocal, as in, even if you are using software as a service distribution model, where you are distributing your services over the internet, over a network, then this AGPL will still apply. It will hold true and it will ask you to share your code, make your code public. That's what this AGPL license is. In reciprocal, this is not there. If you're distributing your software or your product offline, then you have to share your code, or else it is fine. You can use software as a service model, and it would be completely fine with it. The third one, as permissive one, is the reciprocal licenses. So only the open source code part that you have modified to use in your application or your project that needs to be shared. That's the weak reciprocal. And the last one, the friendliest one, is the permissive licenses. It has very bare minimum restrictions, as in you can use them freely. They are good to go. In the table below, you can see the different license families and couple of the examples. AGPL example is GNU Afro GPL licenses. Similarly, for reciprocal, we have GPL licenses and Sun GPL. For weak reciprocal, you have Eclipse public licenses and so on and so forth. And so the permissive licenses, they are Apache Artistic BESD licenses. These are very popular. Mostly you will find weak reciprocal and permissive licenses. But there are some cases where there will be AGPL licenses, and that's why you need to have a detailed software composition analysis done. So now we understand by doing a detailed software composition analysis, we can track down security issues, risks associated, and also the licenses risk. Here, as we can see, if we get to know what all components we are using, we can simply find out what are the licenses associated with them, and we can determine whether these are like permissive licenses or AGPL licenses, and we can compare them against our distribution models and see. Exactly. So here, this is a one more slide talking about the obligations in simple word. For AGPL, you have to share your full code even if you're using for a network user. For reciprocal, you have to share your code if you're distributing it offline. For weak reciprocal, only the modified part needs to be shared. And there is one more commercial license, non-commercial licenses, and this is also a restrictive one. So these are all the licenses which are kind of restricted in some way in different orders. For example, AGPL is at the top. So these are some of the licenses you should worry about. You should be aware of them if they are there in your application. Fine. So to support the understanding of the licenses, let's see a real life case study which happened. There's a company Equifax, so which had created Ghost Script, which was basically PDF editing library. So and they had registered that with dual licenses. That means it had two licenses attached to it. One was the regular open source GPL licenses, which is mind you again a restricted one, and the other one was their commercial licenses. So which means either you can buy one of them, abide by one of them. I mean, if you're buying the commercial licenses, then it is fine with them, or else you have to abide by the terms and conditions and obligations mandated by open source GPL licenses. So Handcom was one other organization which used this Ghost script library into one of their products. They did not go for the commercial license. So now they were supposed to oblige to the GNU terms and conditions, which they actually failed to do. So what happened? So Handcom did not provide the source code. They did not make their source code public, and they did not even purchase the commercial license. So which put them in conflict with the licenses obligation which is associated with GNU public licenses. So that was the whole scenario. So what happened? So for this, Artifact sued them, and in the end, so federal court ruled in the Artifact's favor, and they went for a settlement. So it is really a problem if you're not handling, not managing your components licenses well, then this can seriously jeopardize the ownership of your source code. So this was all about the licenses risk. So now we have covered the operational risks, the security risks, how it can make your entire source code vulnerable, and also the licensing risk that is involved, right? So now let's see what are the approaches available to perform SCA, conduct SCA. So obviously there is one manual approach and the other one is automated approach. So here we have a quick comparison between them. So manual approach is little cumbersome. It takes a lot of time. It's tedious. It takes high effort. Like it takes a lot of effort. Requires because as it requires constant developer input. The developer has to constantly set and update all the open source softwares that are or components that are being used in the project. It's not that scalable as in if you decide to make your project very big, like try to scale your project, again you have to do the entire process again, and you have to eliminate the duplicate components, and it can add false negatives. Since humans will be working on it, there are chances they can miss here and there some of the components while creating and coming up with a comprehensive bill of material. So that's all about the manual process. So when we talk about the automated process, it's actually the opposite. It's very fast as it is automated. It requires low effort compared to our manual process. It's scalable and easy to integrate because most of the automated solutions there in the market, they are exposed with REST endpoints, which can be used to integrate in any pipeline or with any tools. But one major disadvantage you can find in some of the tools is reporting false positive. They will over-report some of the components, and that you have to filter them out. So that's one of the downsides of using automated process. One second. Yeah. Let's talk a little about the manual process. So in order to conduct a comprehensive software composition analysis, first you need to scope all source code base, as in you need to have all the dependencies at one place inside one folder where you want to conduct the software composition analysis. For that, what you can do, you can build the source code so that all the dependencies are downloaded in the folder which you are gonna perform. Okay. So the next part is compiling a comprehensive bill of material, as in coming up with what all components are being used, and what is the current version which is present in your application or the project. Similarly, the third one is associating or listing out the associated security issues with them. For that, you have to list out all the CVEs present in that very open source software. For that, you can use NVD, your vulnerability databases, which is an open source vulnerability database. Okay. And in the end, you have to identify and also analyze the associated licenses that we discussed just now, so that we are not facing with any legal issues, as in we are not violating any of the terms and conditions or obligations of those licenses. So that's what we do in a manual approach. So that's why it is little cumbersome and it's time taking, because we have to do it all manually. The next one is the automated solution. So obviously it's very fast. And so here basically we use a utility or a tool to carry out all the process. And here we can see there are two types of automated solution. One obviously being free and open source, and the other one is commercial one. Some of the very popular free and open source solutions to SCR, NPM audit, which helps you to find out all the vulnerabilities which are there in your NPM package manager. Similarly, for all your JavaScript based frameworks, you can use Retire.js. These are the open source tools. You can search for them and you can also use them. So one is our OAuth dependency check, which gives you a very comprehensive report about the security issues that you get that you have in your entire project. And for our license compliances, we have Fossology, a very good tool which will tell you about the posture of your licenses so that you do not run into any legal trouble. So that's some of the very popular free or open source solutions. And when we talk about the commercial solutions, there are many in the market. One is obviously Black Duck from Synopsys. Then there is White Source, Sonatype, Veracode, and many more. So depending on the criticality of your application, you can actually decide what solution to go with. If your application is small and easily manageable, you might go with a free and open source tool where where it will help you to eliminate the time, as in the extra time you put while doing it manually, so that you can go with a free and open source tool, and you can list out all the components and do your review. These are the factors which will tell you which solution to go with. So in the end, so that takes us to the end questions, which is where do we put this software composition analysis in our application security pipeline? So as we saw, we already have SaaS at the beginning. Actually, it's not at the beginning. Once your code starts to take shape, then we have SaaS done, the secure code review. Before that, we also have ARA, that's architectural review. And at the end, we have our dash. So actually, software composition analysis should be done together with this SAST or secure code review, so that while fixing the issues of the secure code review, all the software composition analysis issues are also fixed, because essentially these are the issues in the source code only. Either you have to upgrade your component, or you have to change, or maybe in worst case you have to write your own code. So this is the overall this is how your pipeline application security pipeline should look. So this was all about software composition analysis. And here I have put out some interesting links that I have referred, and you can also refer in understanding software composition analysis. And these are the links that I've used in my PPT also. So this was the end of source software composition analysis. I hope I have given a good understanding, a basic understanding of what this service is and how important it has become in today's world of software. And with this, I would like to summarize. So today we saw what open source softwares are, how important software composition analysis is, what are the different security license and operational risks associated with them. We also talked about the solutions, the automated and the manual one, and some of the solutions like free solutions and the commercial solutions. So this gave a complete picture about software composition analysis. So this was all from me. I hope you enjoyed this session. Thank you.
I think one more thing I could add to this is another tool called as DependerBot. So that kind of comes with as part of the GitHub. I think
Okay.
recently
Yeah.
GitHub made an acquisition on buying this company called DependerBot. So that's also pretty good. So I think one more thing that I want to add is with respect to OWASP dependency check. That's a pretty good tool that you mentioned, but
Yes.
it's more to do with the Java and .NET based
Yes.
application.
Exactly.
Nikhil,
Yeah,
I would contradict on that because there are multiple languages that it support now. If you can go
yeah,
back to dependency check, there's a whole listing of applications or the code that it supports
yeah,
and the
yeah.
kind of dependencies.
Okay, okay.
But yeah, it was a good discussion. We will end the stream now, and we will see you at the next stream in 15 minutes.
Okay. Thanks,
Yeah.
everyone.
Thank you. Thanks, everyone.
Thank you. Thank you so much.